still looking at 6.2, lesson 6.2, and we're on task 2, residuals and best fit lines. Analyze squared residuals. Different people may find different lines to fit for the same data set. You can use the sum of squared residuals to compare different lines of fit. The closer the sum of the squared residual is to 0, the better the line is of fit. All right, so the closer the sum of squares is to 0, the better the fit. All right, it says the table gives data about the tolls on the Massachusetts Turnpike. In the table, the variable D represents the distance in miles that you travel from the western end of the turnpike heading towards Boston. The variable T in dollars is the toll that you pay when you leave the turnpike at one of the turnpike's exits. Adam and Helen each modeled the bivariate data with a line of fit. All right, Adam's line of fit, T equals 0.03D, and Helen's 0.35D. All right, so just looking at those equations, I'm going to guess ahead of time that Helen's is better because hers has more decimal places. So usually the more decimal places, the better it's going to be, like as far as rounding goes. All right, so it gives us our table of value here. So it shows the distance traveled, I guess, here, and then this would be the amount of tolls. T is in dollars, and D represents the distance. All right. All right, to analyze Adam's model, use a spreadsheet to create a table like the one shown. All right, so we're going to do what we did before. So it says this is for Adam, so Adam's model. So we're going to use the equation above, 0.03 times D. So D is in the first column here. That's in your A column. So you're just going to plug that number in to find the predicted. Then you're going to do like we did before. Actual minus predicted is the residual. And then you're going to take this number and square it to get this number over here. Okay? All right, so it says, what are the formulas in Adam's model to find the predicted T value in cell C2 and residual for D2? All right, so C2, here's C2 is right here. So to find that value, we're going to take the equation, which was 0.03 times A2, which is 0, and plug that in there. All right, for D2, we're going to do B2 minus C2. So this is going to be B2 minus C2. All right, to determine the value in column E, square each residual. All right, column E, so you're going to take and square this. So whatever D2 is squared, that's what E would be. So D2 squared would be E. All right, so it says fill in the predicted values in the third column, the residual in the fourth, and the residual squared in the fifth. Round or write all numbers to the thousandth place. So it means you're going to round it 3 decimal places. All right, so pause the video, go ahead and work on this, and when you finish, come back. All right, so I went ahead and completed my table here, and you can see I just used my calculator to do this. Hopefully you will do the same. Took the equation that we were given, Adam's equation, 0.03 times D. This is the D, or your X value here. So it says D right here. Substitute those in one at a time to get the predicted values. Then subtract like we did in the last one to get this one, and then take this number and square it to get the number on the end. All right, and to square a number, you can use your calculator to do that. Let me show you real quickly. Make sure, so if you want to square 0.167, so if I want to square 0.1, all right, so 0.167, and then it's got a squared button right here. So if I want to square that, that's how I get the 0.028 it says 0.027, but since this is bigger than 5, you round that to an 8 because this does say everything has to be rounded to the thousandth place. Okay? All right, so what is the sum of the squares residual to the model? All right, so if you find the sum, take this last column here, add all of these up. What do you get? You should get close to 0.432. All right, then I want you to do the same thing with Helen's model. So her equation was a little different. It was the 0.035D. So I want you to do the same thing. Take her equation and fill in the rest of the table. When you finish, unpause the video and come back and finish it with me. All right, hopefully you got your table filled in like I did. It does say round to the thousandth place, so if you missed one, that could be an issue. On this last one here, if you used your calculator to square this, it put it in scientific notation, and that just means it's close to 0. So let me show you real quick about that one. So on the last one, you've got negative 0.006. And we're going to square that. And when it puts this e to whatever, that just means it's in scientific notation. So that's basically 3.6 times 10 to the negative 5th power, which means you would move your decimal place this way 5 places, okay? Which means there's a bunch of zeros there. So anytime you see this e, scientific notation, to a higher power, that's probably going to round to 0. So this just rounds to 0 here, and that's because it's in scientific notation. All right, so it says, what is the sum of squares? So now I want you to take this last column again. So take these numbers and add them up and see what you get. So again, you may need to pause your video for a second to do this. All right, if you did this, hopefully you found that the last column there added up is close to 0.123. And so it says, which statements are true? Select all that apply. All right, so we can say that Adam or Helen's model is best fit. So Helen's model would be best fit because remember it said the number closest to 0. So 0.123, that's Helen's. And Adam's was 0.432. If you go all the way back to the top here, the closer the sum of squares residuals is to 0, the better the line of fit. So that's why we have to do that. 0.123 is better. The lower the sum of squares, the better the fit. That is true. And when the sum of squares is lower, the actual values, our predicted values, are closer to the average. When the sum of the residuals is lower, the actual values and predicted values are closer on average. So when the sum of squares is lower, the actual values and predicted values are closer on average. That should be the correct one. All right, that is all for task 2. If you have any questions, please let me know.